Hey, what's up, guys? In today's lesson, we are going to continue to build on what we looked at last lesson, which was slope-intercept form. And so we're going to continue looking at slope-intercept form, but this time it is going to be in the context of word problems. And I know we just all love word problems, do we not? Yes, of course we do. Here's what I'm going to say. Every single word problem is going to be a different scenario. So I'm going to be giving you some key words to kind of look for, but it is going to be really important that you understand this overall concept. And so I'm going to be emphasizing sort of the relationship between the two variables. We've been talking about input and output, and so we're going to see those in play today. But it's going to be important to understand sort of the relationship between the two. And so I'm going to do the best I can to help you. And I think the more and more you go through some of these problems, you're going to have a clear understanding. And so remember, what I'm going to encourage you to do is make sure that you are pausing and stopping as we are working through and not just, skipping through. Again, whenever you pause, if you want to try to do it before I do it, so you can see if you got it right, to make sure you understand, that is always recommended. So let's dive into this first one. So the first example, it says Elias generally rides his bike at a speed of 8 miles per hour. Okay, so 8 miles per hour. If Elias has already biked 15 miles, okay, so he has already biked the 15 miles, write an equation to represent Elias's distance after X hours. Okay, so we have this first example done, okay? And so the slope is the 8 miles per hour, all right? So we got 8 miles per hour, okay? And so what I want you to see is this is the rate that it's really the rate of change, okay? And so as Elias is riding his bike, after 1 hour, he has ridden 8 miles. And so 8 miles per hour is the rate of change, okay? The y-intercept is the 15. Well, in this problem, the 15 is what he already biked, okay? So in other words, in some way, the y-intercept is kind of the starting point, okay? It is like when you have not gone on the x, or in other words, when you haven't ridden for any hours, where do you start, right? He's already biked 15 hours in this scenario, but the y-intercept is the starting point, okay? That's one way we can think about it. And so when we have a slope of 8 and we have a y-intercept of 15, slope-intercept form is when we write it in y equals mx plus b. So we take the slope, which is the m, and the y-intercept, which is the b. And again, the equation is always going to be y equals mx plus b. So it's always going to be written in that format. And so we get y equals 8x plus 15. And now, in this scenario, we're identifying what are the independent and dependent variables. Well, the independent variable is the variable that is connected to the slope. In other words, what is the x? What is that measuring? In this case, the x is the number of hours. Also, another way to think about it is, what is causing the dependent variable to change? What leads to the dependent variable? In other words, the hours go by and then he's driving or riding 8 miles per hour, and that is leading to the distance being changed. So the distance is what is the dependent variable. The distance depends on how long he travels, okay? So again, that is kind of that example, all right? Now each question is going to be different, but I'll try to make some connections to what we have here, okay? So let's look at question number 2. It says, Heaven's fish tank contains So her fish tank contains 3 gallons of water. She slowly adds fresh water to the tanks at a rate of 1/10 gallons of water per minute. Write an equation to represent the amount of water in Heaven's fish tank after X minutes. So we're writing an equation to figure out how much water, what is the amount of water in the fish tank after X minutes. Okay, so let's break this down. Okay, so the slope, again, the slope is the rate of change. How much is it changing all right, over time? Well, the rate of change is the 1/10. In other words, in this one, it is changing 1/10 gallons per minute. Okay, so 1/10 gallons per minute. That is the slope, right? So again, she's adding water each time in this situation. And then the y-intercept is sort of how much does she have from the beginning? What is sort of the starting place? Where does she start? Well, it said the fish tank already contains 3.7 gallons of water. So the 3.7 gallons of water is how much she kind of starts with. Okay, how much gallons she started with. That is the y-intercept. Okay, and so now that I have my slope and my y-intercept, now I gotta write an equation, which is again in slope-intercept form, which is y equals mx plus b. So I'm gonna do y equals m, which is the slope, so 1/10, and then the x. Okay, and again, it might be helpful to know, again, the independent variable is the x, the dependent variable is the y, okay? So y, 1/10 x, then I'm going to put the plus the y-intercept, which is plus 3.7. And so that is my equation. Now I want to identify what is my independent variable here and what is my dependent variable, okay? And so which depends on the other? Well, the amount of, again, it says the 1/10 gallons per minute, okay? So gallons per minute, okay? That is the amount of time, that is how much it is, that goes with the change. The change is happening per minute. So the independent variable is the minutes. Again, what you should see is the x is connected to the slope because it's mx. So whatever the slope is, that is connected to the independent variable, all right? Slope connected to the minutes, all right? And then the dependent variable is, okay, the amount of water in the fish tank after, okay? So it is the thing that is changing. Well, what is changing after the minutes? Well, she's adding water each time. What is changing? That is the amount of water. Okay, so here is the answer to example number 1, okay? Now, again, each of these are going to be different, okay? And so I think over time, hopefully you'll get more of an understanding. So if you want to try question number 2 on your own, I'd say have at it, pause it, and then you can watch me do it. All right? Mr. Hines, there was a typo in my, might have fixed it on your paper. Mr. Hines has an account balance of, has a balance of $375 in his savings account, okay? And he withdraws 15 each day. So he's taking out $15 each day to buy lunch downtown. Write an equation to represent the balance in Mr. Hines' account after X days. So after X days, okay? So let's see. We're trying to find our slope, okay? And again, the slope is the rate of change. Okay, you might It's really important that you understand it is how much it is changing. And we'll just say this is kind of the starting point to kind of help us understand the difference, okay? So the change, the rate that this is changing is that he is withdrawing $15 each day. So if every day he's withdrawing from his account, that is going to be a negative because he's taking that amount out, okay? Withdrawals each day, okay? And then, so he's taking out, all right? And then the y-intercept is sort of the starting point, right? Where does he begin? Well, how much does he have in his account to begin with? It is the $375. That was the balance in the beginning. Okay, so his beginning balance. Okay, his beginning balance was 375. And so now I'm going to write my equation, right? Remember, y equals mx plus b, where this is my m, this is my b, okay? So y, which is the dependent variable, equals m, negative 15, x, okay, plus the y-intercept, plus the b, which is 375, okay? Now, that is my equation. Took the slope, plugged it in for the m, took the y-intercept, plugged it in for the b. Okay, now I need to figure out what is the independent and dependent variable here. Again, remember the independent variable is always the variable that's with the slope. Okay, so again, what is changing? Well, I'm taking out $15. How often? Each day. Okay, so each day I'm losing $15. So the independent variable, again, the thing that's with the slope is the number of days. Okay, so each day, all right, hopefully you see again a connection. It was per hour, and hours was the independent variable. It was per minute, and minute was the independent variable. And this problem is each day, and days is the independent variable. That's a super important connection for you to make, all right? And then the dependent variable is what changes as a result of each of these days. Well, when I'm withdrawing each day, what is changing? What's changing is the balance of the account balance, all right? And so so that is the dependent variable, all right? So again, hopefully you're starting to make some of these connections. We got several more examples. I will tell you this next one is different. So if you try to do this next one before I do it, just know there is something slightly different about question number 3. So I'm going to go ahead and do that one now, okay? And so it says, once it reaches its cruising elevation, talking about an airplane flies at a constant rate of 500 miles per hour. Write an equation to represent the distance that the plane travels in X hours, okay? So, again, our slope is the rate of change, how often the airplane is changing. The airplane's altitude or elevation is changing, okay? And this problem, what's changing? It's changing at a rate of, again, it told us 500, right, miles per hour, right? So again, the slope is 500, changing at 500 miles per hour. The starting point, or the y-intercept here, okay, at the beginning, where does the plane start? Well, the plane starts on the ground, all right? And on the ground has an elevation of 0, okay? And so I know that 0 wasn't in the problem, but you just kind of got to think about the context here. And, in this problem, because again it's starting on the ground, the y-intercept is 0. Okay, and so that is, we'll just say it's on the ground, hasn't taken off, right? Hasn't begun to fly yet. So our problem is, again, we're going to write in a y equals mx plus b. So y equals, then our slope, right? The m is our slope, which is 500. And then the x, the independent variable, just goes with the slope. And then I'm going to, again, it's plus b, but our y-intercept is 0. So plus 0, but I don't really need to write plus 0. So it's just y equals 500x. Okay. And now to figure out, okay, what is my independent variable? Okay. My independent variable is the variable that goes with the slope. And again, in this case, it is miles per hour. Okay. So the hours is the independent variable. Okay. And so after this a number of hours, all right, after the hour, what changes as a result of time going by? It is the altitude, or it's the distance that the plane is flying. So the dependent variable, what depends on the number of hours, is the distance. So in this problem, it is the distance. All right. Hey, again, hopefully this is starting to make a little sense to you. I'm going to encourage you. I think you could probably just use what you have to do the next 3 or 4 problems. Okay. So again, I'm going to ask you to pause it and to try to answer some of these questions on your own. Okay. If you are stuck and you need to see some more examples, you can. Obviously, you can use this to check your answer. But I am going to walk through the next 4 examples here in just a moment. So see what you can do and then check your work. All right, problem number 4. A car tire is losing 2 psi, which is pounds per square inch, each day. So it's losing that much each day. Okay. If the tire was full containing, right, it was full containing 33 psi, write an equation to represent the amount of air in the tire after X days. Okay. So start with the slope. What is the rate of change? Okay. How much, what's changing? Well, what's changing is that this car tire is losing 2 psi each day. So the slope is -2. Okay. And again, it is losing 2 psi. It's a -2 because it's losing, right? That's being taken away. And it's losing that each day. Okay. Now, the y-intercept. How much did it start with, right? Again, think y-intercept is kind of the starting point. Okay. Slope is the rate of change. Right? So, and then just a reminder is y equals mx plus b. Starting point is the 33. So it was full and it had 33 psi. So it was the full tire in this situation. Okay, it was a full tire. All right. Then we take the slope, put it into the m. We take the not the m. That's the b, right? So we take the m, put it in, take the b, substitute that in. So our equation is going to be -2x plus 33. Okay. And for our independent variable, it is what the variable that's with the slope, right? Each day. So our independent variable is the days, right? And then our dependent variable is the amount of air that's in the tire, okay? It's the amount of air in the tire, okay? Or just the amount of air, okay? All right, cool. Question number 5. At opening time, a donut store has 150 donuts. Again, at opening time, it has 150 donuts at the beginning of the day, right, to sell. The baker sells donuts at an average rate, so they sell donuts at an average rate of 16 dozen donuts each hour. Write an equation to represent the dozens of donuts in the store after X hours. Okay, so again, slope is the rate of change. All right, what is the rate of change? Well, they're selling donuts in this problem. They're selling donuts 16 dozen each hour. So because they're selling, that is and they're losing donuts, or in terms of dozens that they have to sell, it should be a negative 16. Okay, and they're selling these, this number of dozen donuts each hour. Okay, and then the y-intercept is the starting point. How much did they have from the beginning? Well, they had 150 donuts to sell. Okay, so I have my slope, I have my y-intercept. Y equals m, negative 16, x plus b, which is 150. Okay, and then my independent variable is what's with the slope, the variable that's with the slope, which is dozen donuts each hour. So hours is my independent variable. My dependent variable is the amount of donuts. Okay, so the number of donut dozens. I mean, you could have put, dozens of donuts or whatever. It's the number of dozens of donuts left. All right, and that's question number 5. All right, we're almost done. You guys are doing great. Question number 6. The drama club is ready for their spring play. They are hoping to recover the $250 that they spent on props through ticket sales and make a profit. Okay, so they spent $250 to begin with, and they're trying to make more money. So they're trying to make what they spend and then also make more money. And ticket sales for $8 each. Write an equation to represent the drama club's profit after X tickets are sold. Okay, little different, little challenging. Let's see if you got it. Okay, so what is the rate of change? Okay, what is changing? Well, they are selling tickets for $8 each. Okay, so what's changing is the number of tickets that are being sold, and that is for $8 each. Okay, so they're making $8 each for each ticket. Okay, so for each ticket they're making $8. Okay, and then now it says they're trying to recover the $250 that they've spent. So $250 is the starting point, but in this case, because they spent that money and they're trying to figure out what their profit is, that's not money that they've already gained. This actually is money that they've already spent. So that actually needs to be a negative. Okay, and so again, it's negative because of the context. Because they're trying to figure out, okay, how much money did they make after selling tickets, but they had to spend the $250, so that's not money that they made. So they're starting off negative and hoping to end off positive in terms of making more than that. Okay, so that is the money spent on props, before, okay, for the scenery. And so then y equals 8x minus 250 here, okay? Again, the independent variable is what's with the slope. it is the number of tickets. Okay, so because for each ticket they're making $8, and then the dependent variable is the money that they're making is the profit. Okay, so it's like the money that they make. All right, money that they make. The word for that is profit. All right. Lastly, a plumber charges $60 for a diagnostic fee. So he charges $60 to begin with, and then plus a $50 an hour for labor. Okay, write an equation to represent the cost. So we're looking for the cost of the plumber for X hours of work. Okay, so in this, let's figure out the slope. What is the rate of change? So how much money is he charging? What's changing? Is it the $60 or is it the $50 that's changing over time? Well, in this problem, it says plus $50 an hour. Okay, so the change, okay, is connected to how much he's working, how long he's working. So it's $50 he charges. This says an hour, right, for labor, an hour for labor. And then it says the starting charge in this problem is the 60, okay? So he charges $60 to begin with, and then 50 more for every hour that he works. So we take our slope, we put it with the for the m and with the x, so it's 50x and plus the 60, okay? And then the independent variable is the number of hours, because that's with the slope, right? The hours. And then the dependent variable is the cost, right? The amount of the job depends on how many hours he puts in work. All right. So, hey, if you've made it to this video, the end, congratulations. Hopefully you understand. Again, this is it really is important that you read the problem. So a couple strategies would be to read the problem over and over to make sure that you understand before you attack it. And then I also just wanted to point out, listen, these are some of these key words, right? An hour, each day, right? Per, each day, per. So those are some key, notice those key words. Those words are usually with the independent variable, and it helps you determine what the slope are. All right, and so I got a couple practice problems for you to work on. But thank you, and hope this has helped you understand how to take real world word problems and form an equation in slope-intercept form, as well as identify what the independent and dependent variables are. Peace.